In this Prelab video, I will give you some details on how to get IV characteristics of a MOSFET. And the MOSFET of interest is this one, which is in your kit. It's an N-channel MOSFET, so it uses this voltage and current directions. You will be basically getting the ID versus VGS transfer characteristics. And after that, you will get the output IV characteristics, in other words, ID versus VDS. And you would do that for different VGS values. First part is the Prelab simulation, where you will obtain these two plots using Multisim. Multisim doesn't have these transistors, so we are using ZVN2106A. Now, new versions of the Multisim may not even have that. So what you can do is simply copy the transistor into your working environment. So I will be providing the schematics for that. So the schematics I'm providing is the tweak version of this MOSFET. So I try to match to this transistor's threshold. So all you have to do is simply copy to your environment. And you will be applying two sources, one at the input, one at the output. In the transfer characteristics, we're setting this fixed at 5 volts, but varying the VGS from 0 to 5 in small steps, while recording the drain current at each step. This is the DC sweep parameter options. And on the output tab, you should be selecting the drain. You should obtain something like this, from which you can derive the transistor threshold by interpolating the value. The next step would be do a nested DC sweep. It is a DC sweep with another source added. The first source has to be the VDS voltage source. The second one is the VGS voltage source. Make sure you enable this. You should be getting something similar to this one, where this is a plot of ID versus VDS at different value of VGSs. So a bunch of curves here based on your setting. And in the analog discovery part, the first thing you would do is to get the ID versus VGS characteristics. And as you can see, there's a triangular wave that you need to apply at the gate. And here are the instructions. So your first channel is at that waveform. The second channel of the scope is on the resistor. So this one is plotting the resistor waveform. So you need to kind of create a math channel to be able to plot the current waveform. And then once you do that, you should be able to get something similar to this one, ID versus VGS. Now the second lab is the output characteristics, and it requires you to apply triangular wave here at the top part, and then the gate gets a step function, and the settings are also included. So if you follow these steps, it should be relatively straightforward. Now it looks like a very lengthy process, but once you use at XY from the view menu, you should get something close to this one shown. Maybe you got one or two curves like this, and you need to also apply the settings before you see something like this. Again, you need to, from the plots, the IV plots at the input, the transconductance value has to be calculated. So not only from simulation, but also from the experimentation. So we're going to be looking at these plots that you obtain and We want you to compare the GM values you find.